Okay, so in this short video, we're going to look at how to write a function that will solve for the real roots of a quadratic equation. So I've written here to solve for x in the equation ax squared plus bx plus c equals 0. We use the quadratic formula given by this. So that is how we find the roots to a quadratic equation. The a, b, and c are just going to be values that are given to us. And they can be anything as long as the a is not 0, because if the a is 0, this x squared term will collapse and we won't have a quadratic. Uh, okay, so let's look at the code. Um, for the show quadratic function, code was taken from ChatGPT, so I've commented that away just to be transparent that this function here, it was taken from ChatGPT, but all it's doing is taking the a, b, and c, which correspond to the a, b, and c in the equation here, and writing down we are solving and then the equation listed. So we'll know every time uh, we call the show quadratic function, it will show us the equation we're trying to solve. So then let's actually look at the solve quadratic function. So I've defined a function called solve quadratic, again inputting the a, b, and c, which correspond to the a, b, and c in the equation. I'm calling the show quadratic function, and that's, again, just to list the equation that we are solving. And then I've listed some variables here, k, u, and s. Why did I use k, u, and s? I have no idea. You can call them whatever you want, but I'm just assigning some variables here that will make the working a little bit easier. So I've assigned k to be b squared minus 4ac. So if you look up here in the quadratic formula, the b squared minus 4ac is what we see under the square root sign. So that's going to be important, because if that's negative, we'll have the square root of a negative number. So in that case, we will have no real roots to the equation. And I've also assigned u to be 2a, so that's the denominator here, and s is going to be minus 1 times b over u. Uh, that will be helpful, uh, especially in the case where this b squared minus 4ac is 0, because then the solution will just be minus b over 2a, because this square root, it'll be plus or minus 0. Um, so I'm just using the if, elif, and else statements here. Um, so when we're doing that, the computer will first check if. So if k is less than 0, remember k is this value under the square root sign. So if that's less than 0, we have the square root of a negative number. And I'm just going to write there are no real roots to this equation. Now, if that is the case, then the elif and else will be ignored. But if the k is not negative, then it will move on from the if statement to the elif, and so on and so forth. So I have elif k, k equivalent to 0. If k is equivalent to 0, as I said, what's under that square root sign will disappear, and we'll just have the minus b over 2a, or minus b over u, which is the s term. So I'll just display there are two real roots given by the s. And if the k is a positive value, then we will get the two roots. And again, I've assigned the root 1, r1, to this s minus the square root of k over u, and root 2s plus the square root of k over u. Again, that's just coming from what's up here in this quadratic formula. And it will display the roots are given by the r1 and r2. So yeah, that's it. Let's run these. So I just ran this big cell here. That's just defining the two functions. And now let's call the solve quadratic function for some different cases here. So I have 4, 3, minus 1. We are solving 4x squared plus 3x minus 1 equals 0, and we're given that, and it will output that the roots are given by minus 1 and 0.25. I think I have a couple more cases here, 0.5, 4, and 8. So if we run that, we are solving 0.5x squared plus 4x plus 8 is equal to 0. And in that case, there are two real roots given by minus 4. And then finally, I have one more case here. If we have the A as 4, the B, or the A as 9 rather, the B as 4, and the C as 2, what we'll get in that case is that there are no real roots because the b squared minus 4ac is going to be negative. Um, so yeah, that's everything for this video. Um, I hope it was helpful. Thanks for watching.